Hello guys, Mr. Hugo here and welcome to another video. Today we are going to be talking about quadratic and order graphics. We are going to start with the quadratic equation where, well, a quadratic equation is always something like this. Let me put it here. Y equals ax squared plus bx plus c. Quadratic equation is always something like this. It has a squared term, a next term, and an independent term. Okay, so for this you have the coefficient a for the x squared, you have the coefficient b for the x term, and you have the independent term c. Okay, again, just like in linear equations, this c here, it represents the intersection with the y-axis. Okay, I repeat that. This c represents in the graphic the intersection with the y-axis. Okay, so let's keep that in mind so we can move on to the next exercise. So the graphic of y equals x squared plus 2x plus c is shown below. Alright, so you have this graphic here, nice graphic, etc. And immediately I look at this and I know some things, and I don't know some things also. So I can write this same graphic like this: y equals 1 x squared plus 2x plus c. Okay, just because when I don't have nothing in the x squared term, that means there is a 1 there. Okay, to have x squared or to have 1 times x squared is the same thing. Okay, just keep that in mind. Okay, circle the correct value of c. Alright, so we want to know our c, and we know that our c is always the intersection value with the y-axis. Okay, is the value of y in that intersection point. Okay, so that's very easy. I look at the chart. Where is the intersection point with the y-axis? Is this one. Where is the value of y in that point? Well, the value of y is 0. Okay, so my correct answer must be this one. Okay, 0. Just for looking at the chart, 5 seconds, I can see 0. Okay. Okay. B. Circle both solutions of x squared plus 2x equals 0. X squared plus 2x equals 0. Okay. Okay. Yeah. Okay. So this initial quadratic equation, if our c is 0, is this equation here. Okay, because it's 1x squared plus 2x. Okay, plus c, but c is 0, so we don't have a c. Okay, and that means that this graphic actually represents this equation here. Okay, so we have two ways of solving this. Okay, we are looking for the zeros of this equation. Let me just wipe this out. Okay, we are looking for the zeros of this equation, and very straightforward. I can look at the chart and I can see the zeros are -2 and 0. Why? Because the zeros are the points where I cross the x-axis, not the y-axis anymore. Now I'm talking about the x-axis, okay? So the points that I cross my x-axis are -2 and 0, okay? You can see the parabola is coming down, crosses the x-axis, goes up again, crosses the x-axis again, and goes up, okay? So we have that the solutions are -2 and 0, okay? Of course, there is another way, an analytic form. If I didn't have the chart, let's solve it without the chart, okay? When I try to solve this, x squared plus 2x equals 0, I can factorize this, and I have, if I factorize, x plus 2, okay, equals 0. Okay, and for this to be 0, one of two things must happen. Either x is 0 or x plus 2 is 0. Okay, and that means what? That means that x is 0 or x equals -2. You see, analytically I must have the same conclusion. My roots, my zeros, they are 0 and -2, which, by the way, are the ones that I have circled looking at the graphic, okay? So, two ways of solving this. You don't have to have a graphic to solve this, but it's easier with the graphic, of course, okay? Okay, write down the coordinates of the turning point of the curve. Okay, the coordinates of the turning point of the curve. Okay, the turning point is the point where the curve stops being, in this case, stops being descending and starts being ascending. Okay, and this point is that one here. Okay, on this point it switches direction. Okay, from going to the downside to going to the upside. Okay, so what I want is the coordinates of this point. Okay, this is a millimetric grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 squares, so this is 5 squares, and this is my value -1 for the y. Okay, the same happens here. 1, 2, 3, 4, 5. If my -2 is there, this is my value -1 also. Okay, so the coordinates of my turning point are what? Are -1, x is -1, and y is -1. So it's -1, -1. Okay, so -1, -1. And there you have your coordinates, alright? Okay, next, number 2. A table of values for x squared minus 5 is shown below. Okay, so we have our table of values. You already saw this in linear equations, okay? This is a little more extensive, a little different, but the result is the same. Those tables allow us to plot the chart, okay? And that's what they ask in Hey. Draw the graphic of y equals x squared minus 5 on the grid. Okay, so that's what we are going to do. So my first point that I have in my table will be -3, 4. Okay, -3, 4, which is exactly in here. Okay, x is -3, y is 4. Okay, my second point will be -2, -1. Okay, if x is -2, y is -1. Whoa, so it will be in here. Okay, that's my second point. My third point, -1, -4. If x is -1, y will be -4, so it will be in here. If it's 0, my y will be -5. If my x is 0, my y will be -5. So we have this one here, okay? And the parabola is always symmetric, so this should be my next point here. 1 minus 4, let's just confirm. You see, 1 minus 4. And the next one, 2 minus 1. 2 minus 1. If my x is 2, my y is minus 1. Okay? Okay, if I have plotted the charts, I now have to make the curve. Okay? And you gotta know when you design a parabola is always something like this. Okay? This is a parabola for the upside. This is a parabola for the downside. So you cannot draw something like this. Okay? That will be completely wrong. Okay? The examiner will know that you don't know what a quadratic equation is and what is the shape of the curve. Okay? So you always gotta do this concave shape. Okay? Okay, let me just wipe this. Whoops, sorry for that. Alright, so I have my dots. I will try my best to draw a good curve. Let's see. A parabola is always symmetric, alright? It's always symmetric. Okay. Looks good enough to, if you do an answer like this, you'll be on full marks. So, yeah. Use the graphic to estimate the negative solution of the equation x squared minus 5 equals 0. Okay? Okay, so we have the chart. Again, when I have something like this, I want to know the zeros. What are the zeros? The zeros is where the function touches the x-axis. Okay? I will say it again. Is where the function touches the x-axis. And that will be in this point here, on the positive side, and in this point here, on the negative side. Okay? And they are asking you for the negative one. Okay? To estimate the negative solution of the equation. Okay? And give your answer to 1 decimal place. Okay. Estimating. We are estimating. So this is, we don't really know for sure what is the point, but I think to 1 decimal place we can do it. Let's try it. I am between -2 and -3. So I have in here, I have -2.1, -2.2, -2.2, whoops, sorry guys, -2.1, -2.2, I would say -2.3 would be quite a good estimation, alright? Could be, I think that, yeah, we can accept, in this kind of exercises, we can accept something probably between 2.1 and 2.4, something like that. There must be a margin of error because we are not perfect designing those parabolas, you know. Normally only computers can design the parabolas perfectly, all right? So I would say 2.3. I cannot be too far away. Okay, so I would say 2.3 is a good estimation for this exercise. Okay, but you will not be wrong if your answer is 2.2. Okay, and you also not be wrong if your answer is 2.4. There is always margin of error in this kind of exercises. All right, so yeah, a good estimation will be 2.3. Okay, x equals 2.3. Okay, guys, I hope you enjoyed the video. I will do another one in a while. I will keep it coming. Subscribe and give it a thumbs up if you like it. Alright, cheers, have a nice one.